Hello, third graders. This is Mrs. Smith here. Today we are doing Unit 1, Lesson 11, which begins with this sheet. Now, if you forget, the way you use this sheet is first you take a little bit of time when you read through it and you say the facts out loud to yourself, like 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9. Then you give it to a friend, family member, or loved one, and you say, can you please quiz me on my 3s? And then they go down the list and they say, what's 1 times 3? And then you say 3. And they say, good job. What's 2 times 3? And then they say 6. Or you say 6. And then they say, good job. And then when you get one wrong, they tell you the correct fact. So if you say, they say 4 times 3 is 15, then they say, nope, 4 times 3 is 12. And then you say 4 times 3 is 12. And then they go do a couple more. And then they come back and they say, what's 4 times 3? And you say, oh, 4 times 3 is 12, right? It's really, really, really important you do this. I also teach 4th grade. One of the biggest things that 4th grade teachers need their 4th graders to be able to do is rapidly know their math facts. So if for every single problem you're having to like count on and draw a picture, it really slows a lot of things down. So please practice your facts for like 10 minutes every day, okay? One way you can do that is here for the next like bunch of pages. All these pages are flashcards for you to use. So you'll cut these out and, tell yourself the problem, look at the back, see the answer, and then here you can also see like a little area model, a little fast array for you. And I want you to notice with this model, it also looks pretty much exactly like one of those division problems too, right? With the product in the inside and then the factors on the outside. Pretty cool. So cut these out. Put them in an envelope, practice them, make them part of your routine. If you have some that you really have down pat, you can put those in one pile, and if you have some others that you are struggling with more, put those in a different pile and practice those ones more, because then you can move them into the I already know these ones pile, okay? Make sure you're practicing your math facts. I can't say it enough. All right, once you're done with that, you can hit play on this video, and then we will do this page. Okay, so pause, cut these out, put them in an envelope. Okay, and then we'll do this in a moment. Okay, so just like we were looking at this area model thing over here, you can use your multiplication along with the idea of area. Now, area is the amount of space, like two-dimensional space, length and width, that is covered. So think of like an area rug, right? One of those rugs in a classroom or maybe in a living room or dining room. It's a big old rectangle and it covers a certain amount of space on the floor, but it's not like tall, right? That's like volume. Okay, so it says the area of a rectangle is the number of square units that will fit inside of it. Write a multiplication equation to represent the area of each rectangle. Then shade a whole number of rows in each rectangle and write a multiplication and addition equation to represent the area of each rectangle. So if you want an example of what that looks like, you can see right here, this side they left 3, this side is 7 long, and then you can break that up into 5 plus 2, and then they're trying to help you understand something called the distributive property, which we'll definitely use in 4th grade and a little bit here too as well. But it's just showing that 3 times 7 is the same amount as 3 times 5 and 3 times 2 put together. That's all we're doing, right? And if you think of the word distributive, it's about passing out. Like if you distribute some invitations to your birthday party, you're giving one to each kid. So with this distributive property, we're distributing the 3 to all parts of the 7, the 5 and the 2. Okay, it sounds fancy, but it's really not that crazy. Okay, so for this one, we'll count how many lengths we have here. 1, 2, 3. And then we'll count how many we have over here. 1, 2, 3, 4, 5. We'll break 5 up. Let's do, 4 plus 1. So we'll do the 1 over here, and then we'll do the 4 over here. So 5 times 3, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 5 times 3 is 15. What's 5 times 3? 15, right? Because you're practicing, I can tell. All right, then right here, we're going to write the equivalent things, right? The little addition problem of the 2 multiplication problems. So we have 3 times 1 equals 3, and 3 times 4 equals 12, and then 3 plus 12 equals 15, which equals 15. It's the same, right? The same amount. Alrighty, let's do this one here. We got 1, 2. And over here we got 1, 2, 3, 4, 5, 6. Now let's break that 6 up into, let's do 5 and 1. Now that's something you're more likely to do than 4 and 1, because people often have their 5s memorized super easily and their 1s obviously like really fast, right? So 5 plus 1 is 6. Let's do 5 times 2, which is 10. 5 times, oh silly me, 1 times 2, this 1 times 2, which is 2. So both of these chunks, this group of 2 and these 5 groups of 2, all together, when you put them together, it's the same amount as all of these 2. 6 times 2 equals 12, because 10 plus 2 equals 12, right? Yeah. All right. For number 3, here we go. We have 1, 2, 3. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 4, 5, 6, 7, 8, 9. Yep, 9. Okay, I'm going to break that up into 5 and 4. So I'll go 1, 2, 3, 4, 5. Whoop. And here's 4. So we're saying that this 3 times 5 and this 3 times 4, when you put them together, will be the same amount as 3 times 9. Right? Which makes sense. 3 times 5, we already did that one over here, right? 3 times 5 equals 15. 3 times 4, we did that one also somewhere, didn't we? Yeah, we did it right there. Equals 12. And then 3 times 9, which is 5 and 4 together, equals 27, which, wouldn't you know, 15 plus 12 is 27. And a fancier way to write this, and don't stress out because you'll do it later, but it's no big deal, is 3 times 9 equals 3 times 4 plus 5. And that equals 3 times 4 plus 3 times 5, which equals 27. Like a little equation chain. Isn't that fun? Okay, next one. Make a rectangle drawing to represent each problem, then give the product. So, 5 over here, 3 over there. There's a rectangle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now it's important when you're drawing your little rectangle picture, when you're slicing up your rectangle, you don't need to draw that last line to get to, like if this line was the 5th line, then what would that line be? The 6th line? Why would you need a 6th line? You don't. So just remember to count that line as your 5th one. So 5, 4, 3, 2, 1. Okay. So let's count these squares, or maybe you remember what's 3 times 5. What's 5 times 3? It's 15. 2 times 7. There's our 2. And then 1, 2, 3, 4, 5, 6, and there's our 7th line, 7 right there. 7, 2. We can count by 2s, right? 2, 4, 6, 8, 10, 12, 14. What's 2 times 7? 14. What's 7 times 2? 14. What's 3 times 5? 15, right? Because you're practicing. It's important. All right, 2 times 9. Let's do sideways one. Hey, why not? Here's our 2. And then 1, 2, 3, 4, 5, 6, 7, 8, and our last line is there. It's the 9. We can count by 2s. Here we go. 2, 4, 6, 8, 10, 12, 14, 16, 18. What's 2 times 9? 18. What's 9 times 2? It's 18 as well, right? All right, let's flip over to the back. Here we are just continuing with what we did on the front side, talking about how you can distribute a number to all of the parts of that number, right? You can make sure that everybody gets their little birthday invitation. The large rectangle has been divided into 2 small rectangles. You can see that there. There's the green one and the yellow one. You can find the area of the large rectangle in 2 ways. The 5 times 3, which is 15, and the 2 times 3, which is 6, add them together, 21. So that's one way you can do it, and that's using the distributive property, like we said, making sure that 3 goes to the 5 and to the 2. If it only went to the 5, you'd only be talking about this much of the rectangle. Because you get it to that part of the rectangle too, it works. Another way you can find the area is to multiply the number of rows in the large rectangle by the number of squares in each row. So 7 groups of 3, which is also 21. Okay. Mostly important that you understand, though, that whichever approach you take, you will get the same answer. There we go. Break my book binding a little bit like that so you can see it. So because math is organized and systematic and not random, one idea should easily transfer to the next because that's how math works, right? Okay, now we'll go ahead and work on this one, which is very similar. Find the area of the large rectangle, so this is 6 by 3, by finding the area of the 2 smaller rectangles and adding them. So here we have 5 times 3. So we're doing 6 times 3. You know what, I'm going to set it up like this. 3 times 6 is equal to 3 times 5 plus 1, which is equal to 3 times 5 plus 3 times 1, because the 3 goes to the 5 and the 3 goes to the 1. 3 times 5 is 15. 3 times 1 is 3. Put them together, what do you get? 18, right? Then, if we multiply the number of rows by the number of squares in each row, 3 times 6, 6 times 3, potato, potato, either way. Let's just count on. So 3, 6, 9, 12, 15, 18, right? Okay, next one, here we go, just a little more practice with this idea. Find this product. So 5 times 4, 5, 10, 15, 20. What's 5 times 4? 20. What's 2 times 4? 4 plus 4? 8. Now, how can you use that to answer this question? What is 7 times 4? What do you think? Well, you know that 7 equals 5 plus 2. So that means that 5 times 4 plus 2 times 4 equals 7 times 4. And this part was 20 plus 8, so that equals 28. All right, So once again, make sure you are practicing your math facts, getting someone who loves you to quiz you, noticing the ones that you're getting wrong, having them tell you which one you got wrong, repeating it back to them, they repeat it to you, you repeat it to them, give them a high five, tell them thank you for helping you practice, and that's it for today. All right, catch you next time, see if you have an assignment, and I'll see you later. Bye-bye.